Lesson 7.1. Let's try and see if we can decide if a triangle is a right triangle by using the Pythagorean theorem, because that's the converse of it. You can use a Pythagorean theorem on triangles, and triangles, if you're given a triangle, you can apply the Pythagorean theorem to see if it's a right triangle. So again, right triangles can use the Pythagorean theorem, and the Pythagorean theorem can be used on triangles to see or prove if it's a right triangle. So the first one here, we have 3, 4, and 5. So if we focus on that one, and we apply the Pythagorean theorem, we would say 4 squared plus 3 squared equals 5 squared, which gives us 16 plus 9 equals 25, and 25 equals 25. It works, so therefore, yes, it is a right triangle. On the next one, again, you don't have the box in there now, so you have to look at the picture and decide what are the legs. And the two legs, well, the hypotenuse is the longest. So that's kind of the rule we go by. So on this one, we have root 5, root 3, and root 8. Root 8 would be the longest. So if we apply Pythagorean theorem to this one, root 5 squared plus root 3 squared equals root 8 squared. Now remember, the square of a square root cancel each other out. So you get 5 plus 3 equals 8. So 8 equals 8. Yes, it is a right triangle. Alright, next one. Again, understanding that the longest side is the hypotenuse, which helps you decide which two sides are the legs. So you get 25, 121, and 169. These two added together give you 146. Which is not equal. So no, it is not a right angle. Now if you've noticed, sometimes we get numbers that work out, meaning no roots, no radicals left, and they're called Pythagorean triples. For example, this first one was 3, 4, and 5. No radicals, and it works out to be a right triangle, so that's called a Pythagorean triple. So 3, 4, and 5 are Pythagorean triples. Another one is 5, 12, and 13. And multiples work also. Meaning if I took 3, 4, 5 and multiplied everything by 2, I'd get 6, 8, and 10. So would also work if you did the Pythagorean theorem. If I multiplied this one by 2, the bottom one, I'd get 10, 24, and 26. Or excuse me, yep. And these are considered Pythagorean triples, and so on. So this ends Lesson 7.1 on Pythagorean triples.